So, when you hear the phrase Internet of Things, what pops into your head? Probably a smart fridge, right? Or maybe one of those voice-activated toasters. But what if I told you that the very same technology is being used right now to coordinate drone swarms and to detect troop movements on a battlefield? Yeah, we're going to dive into this because IoT is so much bigger and honestly a lot more serious than most of us ever realized.
So here's the game plan. First, we're going to blow past those smart toasters to see what IoT is really all about. Then, we'll get into the nuts and bolts, the essential building blocks, and how all these things actually talk to each other. From there, we'll look at how a single, simple sensor can become part of a massive global system, see how it's changing everything from our cities to modern warfare, and finally, we'll get into the big one. Is all this tech a promise, or is it a peril?
All right, let's start right there with that smart toaster idea. Because for most of us, IoT is just about convenience. But the reality? Well, it is far, far more interesting than that.
This right here is the core idea we need to wrap our heads around from the get-go. I mean, a coffee maker that starts brewing when your alarm goes off? That's cool, it's one thing. But the exact same underlying technology is being used for things that are, well, they're the opposite of convenient. They're absolutely critical.
And this is that high-stakes reality I'm talking about. We're talking about systems that give soldiers real-time battlefield awareness. We're talking about drone swarms that can coordinate their actions instantly without human intervention. Or, on the flip side, systems that can be used to launch cyber operations and attack critical infrastructure like our power grids. This isn't some sci-fi movie plot. This is what's happening today.
So this begs the question, right? If it's not just about cool gadgets that make our lives easier, then what is the Internet of Things really at its core?
Okay, so if it's way more than just gadgets, how does it all work? Let's pop the hood and unpack the essential components, the building blocks that power everything from a smart thermostat in your house to a military sensor grid on the other side of the world.
Now, the official definition here, it sounds a little academic, I know, but a couple of phrases here are absolutely crucial. Global infrastructure and interconnecting things. See, the goal isn't just to stick a Wi-Fi chip on everything. It's to enable brand new, advanced services by letting all those things talk to each other and share data. Think of these 5 steps as the fundamental recipe for any IoT system. First, you have to give every single thing its own unique identity. Then you need a way for it to sense the world around it. After that, it has to communicate that information over a network, where it's all processed or computed. And finally, all of that work leads to an application, the actual service it was designed to provide.
And you can really think of this as the two hands of IoT. On one side, you have sensors. These are the inputs. They gather data, things like temperature or light or motion. And on the other side, you have actuators. These are the outputs. They're the things that take action based on that data, like flipping a switch, opening a valve, or turning a motor.
All right, so we've got the building blocks. We have the sensors and the actuators. But how do they actually connect? How do they talk to each other? Let's take a look at the languages and the blueprints they use to make that happen.
Before IoT was a big buzzword, we had M2M, or machine-to-machine. It was usually a direct point-to-point link. IoT is a huge leap forward. It's IP-based, which means it uses the same protocols as the internet. It's cloud-based, which lets it handle massive amounts of data. And it's built from the ground up to scale. It's really the difference between two people talking on a walkie-talkie versus everybody communicating through the entire internet.
And just like we humans have different languages, all these devices use different communication protocols. Think of it like this. You wouldn't use a giant semi-truck like HTTP just to deliver a tiny urgent letter. For that, you need something small, light, and efficient, like MQTT, which is designed for tiny devices that might be on a shaky network. Each protocol is just the right tool for a specific job.
So how does all this data flow? Well, this simple 3-layer setup is a really great model. Down at the bottom, you have the device layer. That's the things themselves, the sensors and actuators. In the middle, you can have what's called a fog or edge layer, which basically does some local processing to speed things up. And then at the very top, you have the cloud layer. That's the global brain where all the heavy-duty analysis and data storage happens.
Now, how do these systems actually scale up? It's really important to remember that IoT isn't just one single thing. It's a whole spectrum of complexity, all the way from one lonely device to a massive interconnected global system.
This progression right here is key. You start out super simple at level 1, with a device that does everything itself right on board.
But the real power, the magic, happens when you connect it. By level 3, the cloud isn't just storing the data, it's analyzing it, looking for patterns. By level 5, you've got multiple devices working together like a team through a local coordinator. And then at the highest level, level 6, you've got a fully centralized system where tons of independent devices are all being monitored and controlled from one single place. Every step up that ladder unlocks more power and more intelligence.
Okay, so that's enough of the theory. Let's bring this out of the abstract and see what it looks like in the real world. How are these ideas being used right now, in our cities, and, well, beyond?
In our so-called smart cities, IoT is basically everywhere. It's helping to manage parking and traffic flow, it's running surveillance systems, and it's even doing things like monitoring the structural health of bridges to predict failures before they can even happen.
And it goes way beyond just cities. This is a great example of a powerful use in agriculture, using IoT sensors to build a fire detection and anti-fire system. The goal? To protect crops and improve food security for all of us. This is about solving huge, global problems. And this brings us right back where we started, full circle, to the battlefield. Here's a concrete example of everyday civilian IoT being exploited for military intelligence. We're talking about Russian forces hacking into totally normal surveillance cameras, the same kind you'd see in a smart city project, to monitor defenses and track supply lines. And that leads us to the most critical part of this whole story, what I'm calling the double-edged network. Because with all this incredible power comes this deep, profound duality.
So the crucial point is this. IoT is a dual-use technology. The very same connectivity that can make our farms more productive and our cities way more efficient, that same network can be twisted and turned into a tool for surveillance and for sabotage. That is the fundamental tension that we have to deal with.
Which leaves all of us with this final, incredibly important question. The drive to connect every single physical object on the planet to a global network, it's only getting faster. But as we rush to connect everything, how do we make sure we can protect everything? That, right there, is the challenge that's going to define the next chapter of the Internet of Things.